Hello and welcome to the Learned It, Living It podcast. I'm your host, Adam Walker, and today I am delighted to be joined by some engineering students, a topic that I'm really interested in. Being a technology guy myself, I don't actually know a lot about engineering, so I'm looking forward to this. So before we start, who are we? You start for me over there.
I'm Seth, T-Level Engineering, and I'm just planning to become a robotic engineer.
Just as you do.
Yeah.
I love that. Brilliant. What's your name?
My name's Daniel. I'm a T-level engineer as well, and I'm planning to be an automotive engineer.
Okay, fantastic. And yourself, sir?
Bailey, the same T-level engineer, and I'm thinking about electromechanical engineering. Electromechanical.
Electromechanical. Right, so I've got three variations. I've got robotics over here, automotive over there, What is electromechanical?
I think electromechanical engineering is just a mix between electrical engineering and mechanical. It's where both are used in the same, you could say the same like example or the same setting. An example of that is an automatic door using sensors and also switches that can like what's it called? Like to automate the door, but also to open and close.
Do you know what? That is the best example you could have given me, because now I just completely understand what that is. When you first said it, I wasn't too sure, but that's perfect. You can control things, right? You can stop people getting in. You can take over the world with those sort of skills. That's amazing. I really like that. The door's a really good example. Brilliant. So what year are we in now?
First year.
First year. So you all started in September. For context, it's currently December when we're recording this, not to date it, just so we know where we are in our journey. What made you come to the college, Seth?
It was just a great gateway into what I want to do. If I get to finish this course, which I hopefully will, I will be able to attend university and end up furthering my goals.
Yeah, and that is robotics.
Great. Yes.
What sort of things are you hoping to do in robotics?
Mainly prosthesis, because it's kind of unexplored field with robotics. Like, you have the prosthesis of legs where above the knee you have Bluetooth joints, but they're not really that effective. They just react rather than actively move.
Okay.
And the hands are a bit clunky because they just work off muscle twitches rather than actual signals.
Right. This sounds complicated already. I love this. This is fantastic. You got me thinking about Neuralink already and stuff like that, technology that's been coming out there. Why then? Why that? What has inspired you to go down that route?
It's less so an inspiration, but it's just something that I've always really wanted to do.
Yeah.
Because it's just a field that is really just the future, because a lot of companies need robots, a lot of companies need things like that. And as a side thing, prosthesis should also be considered within the whole field of robotics, as robots can help anyone and everyone without much failure.
Yeah, I love that. Great. That's fantastic. Why automotive engineering? So what's led you to this? Obviously, you're here now in December. Well, why did you go down the route of this course, and why did you pick the options that you went for?
Well, ever since I've been little, always had a thing for cars. It's just whole life, all I've wanted to do is cars. And then finish school, and then I was looking for a college, and Darlington College was close. Then I saw the T-level. I was like, that's perfect. It can get me into uni after, or maybe get me an apprenticeship after. So I decided I'll take the T-level in engineering. And now I'm doing this, and then hopefully after I do this course, I'm hoping to get a degree apprenticeship with a car brand. Fantastic.
So is T-level the thing that stood out to you when you're looking at your options? It sounded like university and things like that. Is that the driver?
Yeah, I didn't really know what the T-level was, and then I read into it, and it could get me into uni, which is where I want to go.
Yeah, that's brilliant. So obviously the T-level there. And why electromechanical? I'm going to keep saying that wrong all episode. I do, forgive me. Why electromechanical? What has inspired you to go down that route?
Just at first, originally, I first focused on just mechanical, but then when you consider electrical, I think just things like electrical cars coming in the future, a lot of things I think would like transfer from just like petrol powered and things like that to electrical. So I think looking into that field, what we'll be mainly focused on in the future, will be beneficial. So having skills in that field as well as mechanical, it's like better two worlds.
Yeah, I think it's brilliant. I think looking at the current environment that we're
Yeah.
in and
Yeah.
what the world is trying to achieve in terms of electrical and net zero and everything else that they're looking at, I think that's a really good way to go about it. And why T-level?
The main thing was the variety in the amount of different modules, so all of the like throughout the course, all the different things that are covered.
Mm-hmm.
So it doesn't specialise in just one thing, but a variety, which is what I wanted to learn because at that time, I wasn't fully sure on which exact sector of engineering I wanted to go into. I'm still not 100% sure. I'm still just, venturing through, but that is what I have my eyes set on at the minute.
Yeah, it sounds like it gives you a lot of options to
Exactly,
make
yeah.
an informed choice. So I think
Yeah.
that's brilliant and a good way to approach it. The question I've got written down, I'm only wondering what you're going to come out with, Seth, because it says describe your typical day in your program, but you're on about robots and all sorts of stuff. So I'm fascinated. So what's your typical day looking like at college at the moment?
Well, the typical day it varies between the days because on Monday we have the science with Jace, don't we? Like science and mechanical
Yeah.
principles. And that's just the deepest topic that we go into. It's practical maths, it's practical science, and that's our Mondays and Fridays.
Mm-hmm.
And then all throughout the week we have spots of practical, spots of mechatronics, which is just robotics.
Yeah.
And it's just a dotting of different types of engineering throughout the entire
Yeah.
course. rather
So
than
obviously,
just
maths and
singles.
science are a huge part in terms of what you do. So is that more of a classroom session that you're having to do to get the understanding?
Definitely, yes.
Yeah.
Yeah, and then obviously your robotics, is that you get to play with things and get them working and try things out? What sort of projects have you been working on?
We haven't had any projects yet, have we?
No,
Yeah. Oh no, we are working on a conveyor belt now, aren't we?
Yeah, that's
Yeah.
with Jason. Just tell me about one programming the robots.
Yeah.
Yeah, so obviously when we were in mechatronics, you program the robots using laptops.
Yeah.
Yeah, so you give it different like exercises, like different motives to do the task at hand. So what we have done is when there's like a magnet on the end of the arm, so it's like a robotic arm. So just to use that to pick it up, move it around, just different directions, like getting comfortable with the software.
Yeah, I suppose when you think engineering, people are often very quick to think about the physical
Yeah.
elements of it.
Yeah.
But you've already touched on maths, science, programming. Like, I bet, it's the thin end of the wedge when you go into this course, right?
Yeah, we haven't done CAD yet, but that will be our second year.
Yeah,
And
so computer-aided design, for people that don't know what that is, basically design software. So you'll be touching on that as well.
yeah,
Yeah.
I don't think we'll be touching on it. I think that will be a rather in-depth
Yeah.
one, won't it?
Yeah, we've got to fully understand it now.
Yeah. Because obviously you can't really survive in the engineering world nowadays without knowing some CAD.
Yeah,
at
100%.
least.
So it sounds like it gets you really well set up in order taking that next step in terms of career.
Exactly,
And what,
yeah.
you're coming up with. What about yourself in the automotive? What's your typical day? Is it the same with the robotics element, or are
Yeah,
you?
it's the exact same.
Is it so? It's all similar and in there, and then you do different elements
Yeah.
throughout the course. Okay, I understand. What then? If we go each round in turn, we'll start with yourself. What do you think's been? Have you started placements yet? Are you on placements? Are the placements?
I think only 4 people have started.
Some
placements.
have. I've started mine.
Okay, well, tell me a bit about that first, actually.
It was exactly what I described to you before with the automatic doors.
All right, is that where
Yeah.
you've been on placement? Okay,
Yeah.
brilliant. So where are you on placement?
Well, it's just it's not a place. It's like a mobile company.
Okay, yeah.
So just this employer, and we just go travel around. So we've been, where was it? Like very far east, like to the other coast from where we are now.
Yep.
And then just around the country, not as far as Scotland, but near.
Yeah.
And so we just travel. The companies ring up and say they need the door fixing or installing,
Mm-hmm.
and we'll do that and like identify the issue first, reprogram it if needed, and just like check fixings, things like that, and like fit sensors and program them to certain distances, just things like that. And not only that, but we do roller shutters too.
Right.
So, you know, just again checking the fixings, but also checking the electrical side, which is what powers it.
So one part of that you're getting there is obviously the experience of doing the installation or the repair and the work. But how has it been? Obviously, then having to deal with customers.
Customers, all right. Like there's not much been much interference yet. Like, you know, sometimes you get complaints, things like that. But there's not been much yet. I started not long ago, but he says sometimes there might just be a little bit. You know, when you're working on certain like shop fronts, things like that, which is a common thing, just with customers and even customers of the shop, like trying to go through where you're doing. He said that could be a complication, but having two people there just makes it easier. Won't be able to communicate and won't be able to carry on work.
Yep. So one of you is almost keeping the health and safety in place.
Exactly.
People trying to get through the door that you're working on. Yeah. So it immediately opens up to a different sort of set of skills. I don't really want to use the word soft skills because actually they're really important in everything we do, especially in the world of work. But the fact that you're getting that experience with people trying to push past the door that you're fixing and working on. Obviously, you're having to work with colleagues, you're having to travel around, you're having to organise yourselves. I bet it's a really good experience to kind of take forward.
Exactly, yeah. It's not just physical skills, but also people skills.
Yeah. Being
able to communicate with the customers, but also people that might cause complications and working ways around that.
Okay, that's fantastic. And I think for me, in terms of that, one thing is the knowledge. Then the next thing is working on those development skills. And I think they're so important. But I think for me, what would you think about what is your most practical rewarding experience you've had in that placement? Is it those doors that you gave me the example of? Or?
Yeah, I think so. That's the main venture that he does do. But yeah, like learning the interface, connecting the wires, things like that. You know, just onto the boards, just on the circuit boards. But yeah, just learning exactly how things are wired and the sensors, things like that. Just getting more of an in-depth understanding of things that you see in everyday life. Yeah. So just like looking into more detail of things that you might take for granted and what really goes on and how in-depth things can be.
So I bet you'd never walk through a pair of automatic doors in the same way now.
Exactly, yeah.
You came through 2 sets on the way into the building today.
Yeah.
So yeah, that's brilliant. Do you guys end up going on placements? Is part of your course placements? Tell me a bit about that.
Yeah, I haven't got mine yet.
Yep.
It's getting set up with a placement.
Okay.
That is the issue at the moment. But when I do, it'll teach me the skills that I will need in the future. Like as you said, soft or hard skills. It's just you get the work experience. You get to know how to be an employee rather than what would it be?
Rather than just like learning the skills without implementing them.
Yeah.
Is that what you're trying to say?
Yeah.
You could say you're learning it and living it.
Yeah, that's a good one.
There we go. That's why it was picked, because obviously you're learning it in the classroom, but the opportunity for the placements. Have you got a placement lined up at present?
Not yet. I'm currently talking to a metal fabrication company
in
Shildon.
Yeah.
Which I'm hoping to get.
Yeah. Well, fingers crossed with that. What I will say is I've had industrial placements come with my business before, and it's been really valuable to have the placement join me from an employer standpoint and work alongside them and support their studies, but also for employers it can really help you in terms of actually another pair of hands, like in your case, with the example at the shop and people coming past. So a little call out to employers out there. If you're interested in becoming a provider of industrial placements, get in touch with the college. They're always happy to help, and they've got a fantastic team of working. Just a little sales pitch in the middle of there, gentlemen. So what does the next sort of 6 months look like in terms of your studies? So what's the progression that you're expecting to see in terms of learning, content? What do you think that'll look like?
Well, soon enough we'll be doing like the employer set project, won't we? I'm pretty sure we find out in May what it is.
Okay.
Which that should take us a couple months to I don't know how many months, if I'm honest. I know that it's from May to I think June.
Okay.
But the details of it are not even available to the college yet, so we don't know what we're doing and when and how we're actually supposed to.
So the
be
job of
doing
the
it.
college is to give you some skills so that when that comes round, you're equipped and ready to go. What
Yeah.
sort of things are you looking at learning next? Do you know what's on the syllabus next?
We're doing electronics. We've been
Yeah.
doing electronics for
Yeah.
a while.
Yeah, so just trying to get a greater understanding in electronics. In say one lesson a week, we have like deep understanding in electronics, trying to develop it with circuit boards and resistors, things like that, calculations that are very in depth. Obviously, it takes time, and that's why we just further develop. But it's all different lessons where we're trying to develop, obviously, further. So I think we're coming to the end of mechanical principles with our tutor Jason.
I think we've already finished, haven't
Oh
we?
yeah, maybe
No,
we've just
physics.
finished. Yeah, so we're going on to deeper science,
Yeah.
physics. Yeah, with him. So obviously that'll be a lot more in depth.
It'll be like flywheel calculations and stuff like that, I think.
Yeah.
Wow, yes. Okay. Yeah, I can see that maths coming back into play very quickly. Say physics, but there's a
Exactly.
huge amount of maths with things like
Yeah.
that.
The basis of everything is just maths within the engineering course, and
Yeah.
it's heavy, to say the
Yeah.
least.
Yeah. How have you found it? How have you found the maths? How have you found this physics? There's, you think one thing, I'm going to go do engineering. Before you know it, you're doing deep science study, looking
Yeah.
at flywheels, robots, resistors, circuits. There's a whole lot of stuff that's thrown at you on this course. How have you found it?
I definitely didn't expect it. I thought, art engineer, I'm just going to be working in a workshop and just, doing all the fun stuff. But it's been hard. I won't lie, it has been hard. But no, the teachers are good and just explain it to us and making us understand it.
Yeah. And do you think with having all of that, and I suppose this is what makes it the T-level, all of those extra studies, surely you can take all those studies right into the workshop type work
Yeah.
in terms of your understanding? Have you found it's helped you build a broader understanding on why you might be doing something?
Definitely. With
Yeah.
just learning about the materials and things and how they work.
Yeah. What's been your favourite bit so far on the course?
Probably John's lessons when we do things with the robots.
And you're not just saying that because John sat over there off camera. He'll slip you the $5 later. But yeah, so tell me a bit about that then.
We've been working with two different type of robots. So we've been working with the arm one that Bay was speaking about, where you have to program it to pick up these little circle, metal pucks, and make shapes and patterns with them. And then as well, we've been playing about with these little Lego robot things where we make them battle each other in a little arena.
Really?
Yeah.
Take me through that process then. I need to delve deeper into that, if only for my kids than anything else. So, Lego, what is it? Tell me what you do.
It's a robot,
Yep.
which is I don't know, it's-
Lego Technic.
Lego Technic.
Okay, yeah, the Lego Technic, yeah.
And you just add wheels to it. You just make it just make it ready for battle. You just add a load of cases.
Yeah,
Yeah.
you fully modify it yourself. You only start with a little box, which is the programming. So, and then around that you build the wheels and whatever else to try and make it solid,
Yeah.
make it equal, so that it does travel. And then we add sensors
Yeah.
onto the electrical component.
You
know,
program the sensors. on
Yeah.
the gears, so that
Okay.
if it's a wall in front of it, it will turn and doesn't crash into the wall.
And how have you found that process?
That just test and trial. That's what it's been.
Trial and error, yeah?
Yeah, that's
And
what
you-
it's been.
And have you succeeded?
We have now. Yeah, it did take a few attempts where it kept crashing into walls, but
Yeah.
eventually it worked.
But this is where show me an inventor in the world, in history, that created the thing on the first try. A lot of things have been created by accident, believe it or not. So so that's how you do it, right? That's how the professionals have done it over the years. But no, that sounds fantastic. And then you say they were battling. So what would you do?
We put them in just a box of tables.
Okay.
We flip the tables
Yeah.
and we just put them in a box,
Yeah.
and we just let them run until
Yeah, they
one
just-
flipped them, another one over. Or
Oh, so you'd have an aim of trying to flip the other.
yeah.
Yeah,
The sensors would. Sorry, continue.
I was just going to say the last one to keep moving around the arena was the winner. So if some was stuck on the wall, with one wheel up.
Two-time winner here.
Just, yeah, without the ability to keep going and hitting into the other one, then they lose, and the one that's keep moving would win.
So take me through then. What skills have you had to do in order? Because it sounds great, like flipping over little robots and doing all this. But what skills have you had to put in to do that? What things have you had to understand and implement?
It's less like ones and zeros coding or Java coding or Python coding, any of those codings. It's more drag and drop coding. Like,
Yep.
have you ever used Scratch coding?
I have.
Yeah, it's just that format, but
Yep.
it's using the robots themselves, running them through different codes, and just checking if that code works for the goals that we're trying to set. Like the ARM ones, we would manually move it ourselves to one of the pucks, grab it, and then move it up and just set points at each separate area
Yep.
that we needed it to do, and put the commands in through the computer through that process. And it would end up making a pattern when we ran the program.
Yeah, because that would be taking coordinates in 3D space, wouldn't it? Right?
Yeah,
There we are.
exactly, yeah.
Check me out. Not just a pretty face on the podcast. There we go. But no, absolutely. You got a program in 3D space. So you got the 3 dimensions that you need to move in. So would you be saying record that position and almost keyframe it?
Yeah, you can
Yeah.
make it more direct, kind of, with like the exact angle on the axes. Say if you wanted to move it 1 degree or 2 degree more on the y-axis, like to the right or whatever, you could do that instead of just moving it manually, so that it was direct on where you wanted it. But also you could obviously just use your hand, but to make it more direct and more pinpointed, you could use the axes to
Right.
move it.
Fantastic. I love this. This sounds like a fantastic course. I need to come and battle some robots. That sounds great fun.
Yeah.
But obviously with a huge amount of knowledge that goes in underneath it, because you touched on the workshop being the fun stuff. Yeah, that's why a lot of people do
Workshop
it.
with Tom.
Workshop with Tom. Tell me about the workshop with Tom then.
Yep.
Tom,
Uh,
what a guy Tom is.
We've been recently
Shout out to
making
Tom.
toolboxes with Tom, which is where you learned how to rivet. We learned how to bend the metal with using the tools in the workshop,
Yeah.
and we learned how to properly make the toolbox. I'm not going to comment on how mine turned out, but
Trial and error, right?
yeah.
We only had one shot at it.
You only had one shot,
Yeah,
did you?
I'm alright though. Tom helped me. Shout out to Tom.
Is it? So what was it? Where was the tricky bit? The riveting, getting things in the right place. Like, what was
The
the
bending
challenge?
of the metal.
Yeah.
Bending of the metal.
It was
Yeah.
really, really weak metal, so like just one wrong thing.
Yeah.
and You've bent it the wrong way.
Yeah, I bent mine and it just fully sheared one of the bits. Well, not sheared, but it's rolled one of the bits of the actual walls, and it was just hard to recover.
Yeah. Welcome to engineering.
Yeah.
Yeah, I can imagine it, especially with the components you can be working with.
Yeah.
Small electronic components, and you'll be the same with robotics and every element. In truth,
Yeah.
it's like when you finish putting something together and you've got one screw left.
Exactly.
Yeah,
Yeah.
and you're going, that should probably be somewhere in this thing that I've been working on. So,
And it usually comes back when it breaks.
yeah. So you made toolboxes. What have you done? Any other things in the workshop? Yeah,
We
Chance?
have stripped and redone generators a little bit.
Yeah.
Okay.
Yeah.
which-
So just basic things, just like taking out components and like draining oil, refilling the oil, and then just looking inside, seeing how you would take apart the components and what tools you would need.
Yeah.
So it's just basic skills, in my opinion, and then hopefully we'll have some more developed ones in a more technical.
I find it's easy to
examples.
take things apart. It's the bit where you try and put it all back
Yeah,
together again.
exactly.
That's the hard bit, because often it is easy to do that, but
Yeah.
to put everything back together, that's difficult.
Generators also help with if you have any car troubles as well, because they both use basically the same engine.
Right. Okay. Yeah. So you're broadening your knowledge in terms of how it applies across different
Yeah.
areas
Yeah.
and things. So obviously, looking to the future, we're on T levels. You've already touched on what the next steps are, but what do you think about your career? So we've touched on the fact you're interested in university, higher education, but in terms of your career, and you've got an idea, but how do you envision it happening? Do you know the milestones that you need to hit and do in order to get there?
I have a general idea of where I need to do. I need to obviously finish this course, pass it with good grades,
Mhm.
and then I need to move on to to a university that will support the skills that you need for robotics. And I plan to take a master's degree, so
Right.
that it's like, so that I am guaranteed at least something in the
Yeah.
field of engineering. And I plan to do not prosthesis instantly, but like work with actual robots in industry, in fabrication, any of that, before I do try and do prosthesis, because you need the basis rather than instantly jumping to, oh, I'm going to make some person a hand,
Yeah.
which is
Yeah, you kind of need to do the
Really
groundwork and,
complicated,
as I call it, serving your apprenticeship, so to speak. Not an apprenticeship in this case, but obviously get your base knowledge in place, experience, so that when you do put a hand together in the future, you're not left with one screw on the side going, I should probably put that somewhere.
yeah.
So yeah, what about yourself? What are you thinking career-wise?
Well, the end goal is to be working with a big car brand such as like Ferrari or something like that.
Yeah.
That's the aim. So the plan is I've had a look. They do some degree apprenticeships. Brands such as Ferrari, Aston Martin, Mercedes, they all offer degree apprenticeships. The T-level will get me into it. So the plan is to apply for the apprenticeships, hopefully get one, work with them for a few years, and then I think it's a contract where you have to stay with them, and then work with them, and just slowly get higher and higher. But mainly I want to focus on designing and making like the new car models better.
Okay.
That's the
Yeah, so we're getting into aerodynamics and things like that
Yes,
we're
yes.
talking about. What's the interest behind there for you?
interest.
Yeah.
I just find it fascinating, just getting them to go just so fast. So how to make the engines more powerful, how the aerodynamics works to make the car go faster, make it accelerate quicker. Just
Yeah.
find it
And when we're
interesting.
looking at the net zero stuff and things like that, it could even just be how to make them more fuel efficient. I know you're like, I want to drive the car fast. I get it. It's a Ferrari. I understand. but there is an element of that as well, isn't there? Absolutely. And what about yourself, sir?
What was the question?
The career, sorry.
Yeah,
So,
sorry.
you know, you've outlined sort of the next steps that you want to take, but in
Yeah.
terms of career, what are you hoping to do?
I wanted to like complete the course, of course, and maybe stay in that industry, even within the same employer. He'd noted that he was interested in having someone come on with him, so I feel like maybe that could be an option to work with him. But alternatively, maybe similar to Daniel, like either going to uni or a degree apprenticeship.
Yep.
Just to try further my understanding, climb up the ladder.
Yeah.
Just to have a more significant role, higher role in a company.
No, that's fair enough. I think that's great. And I think, judging at how I get to speak to obviously a lot of students with this, I think the fact that you're all doing a similar course, but you've all got your unique focus, I think is absolutely fantastic. And industry placements, obviously, hope you guys get sorted with those soon, and you're away. And obviously, you're getting good experience on the industry placement there. If anyone was thinking about doing this course, each one in turn, I'll start with you.
Yeah.
What would you say to them? Like, why should they do it? And give me a few reasons.
They should do it if they want to broaden their understanding in an engineering environment, and not only physical, but just like not classroom work, but like further theoretical work, I could say, with their math skills and the science skills, understand how things work, looking further in depth rather than just seeing things at face value.
Yep.
So just getting more of an understanding and of different things that might seem simple at first, but when you do delve into the workings and how they do work, then you will understand, and maybe that's what you want. But yeah.
And what about yourself? What would you say to someone who's thinking about it?
Yeah, definitely what Bailey said, but as well, with it being engineering, it opens lots and lots of doors. It doesn't make you just stick with, let's say with me, I want to be an automotive engineer. It doesn't make me, you have to do automotive because that's all you've been qualified for. with it being engineering, I can, if let's say I've changed my mind, I don't want to do automotive anymore, I can go into any other sector and I can go down any other path. It doesn't matter.
So there's versatility in terms of your development, and it kind of keeps your options open, not challenge you into one.
Yeah.
And you might discover something on the course that you go, actually, I'm interested in that and go there. What about yourself? What would you say to people?
I agree with I would say both of these points as well, but I would also add it's a great opportunity to meet a lot of like-minded people and make a lot more friends, or acquaintances might be a bit
Yeah, I guess so.
accurate. Friends and acquaintances, and that will just help you later in life, and it will give you a good challenge in like how much you can actually go deep into certain knowledge, like different aspects of knowledge.
Yeah.
Like deep into physics, deep into the principles of mechanical engineering and all of that.
And deep into how to win robot battles.
Yeah.
Yeah. Twice.
Twice.
You're going to have to put him in his place. I want to go. I'd be useless. It would just fall apart and roll into the wall. But no, I think that's brilliant. And I think in terms of like, one question to sort of finish on now is sort of like, what do you see the future of the space? Prosthesis obviously is a huge area of development. We've had the Neuralink work going on with Mr. Musk, doing most amazing things with technology. How do you see the future of that sector for you?
I would say less invasive stuff would be far more beneficial to people rather than having it's personal opinion, but having a billionaire stick something in your head doesn't really sit right.
That's fair. You're entitled to an opinion.
So I'd much rather have something less invasive, like having take the arm for example again, an arm with electrodes in it that can detect the signal from the brain rather than just detect the muscle twitches and respond in the way that an actual hand would work. What you need to figure out there is soft robotics, which is a whole beast in itself.
How to pick something up without crushing it.
Yeah,
that's what. Yeah, I get it.
How to make things move like a human.
Yes.
Basically.
Yeah, and obviously with human, we can either choose to grab hard or grab soft, or yeah. Okay, I understand that. I think that's a really good way, a really good idea in terms of what the future holds, and I think actually that's probably the way it's going to me. You know, what about yourself? Automotive, obviously, you've talked about going fast in cars and aerodynamics and all that sort of thing. What do you think the future is?
Future, well, we're coming to a time where obviously petrol cars are slowly going away, and we need to move to electric cars. So I think that opens a lot of doors, and the future's going to need people to.
It's going to need people to shape the future, though, isn't it?
Because going into electric cars, everything's changing. So we need new people to learn about how these electric cars work and make them better and faster.
Make them more safe.
Yeah, make them safer as well, because there's been some dodgy stuff with them.
There we go. You guys have the knowledge. And what about yourself?
I just think more and more of the electrical components are being used around rather than manual. Could say people are getting lazier, but it's just I think development of electrical components around the world, even in different sectors, engineering sectors, just how different ones are implemented and how they can be benefited or developed to meet certain needs. So things like, say, mag locks for like safe buildings that need to be secured. Just having that extra safety rather than just a manual door that can be breached. So just with the extra level of safety is beneficial. So mag locks and electric doors, and even with the sensors, only sense one way. So once it's closed, it's not opening.
Yeah.
Just to secure buildings of just like high risk.
Yeah, I think that's
like
a really interesting point. Security. The other thing you touched on is about it could be whether people want to open the door for themselves or done electronically, but that could aid some people, which kind of comes across to what you were touching on, obviously, and not in a prosthesis, but in terms of society, we could have things in place that help people. And I think in terms of engineering, there's quite an exciting future ahead, because we're at the turning point of petrol to electric in terms of automotive sector, and obviously I unfortunately was around to remember when there was no internet. So obviously you guys have got that, but in terms of the internet, it's still relatively young in terms of like how long it's been on the planet, and electronics, engineering all play a vital role in that sort of thing, whether you can remote into things and control them that way, and whether it's controlling physical infrastructure, or whether it's done with a bit of coding. There's a whole world out there to be had for engineers, so it sounds absolutely brilliant. I would like to thank all three of you today for coming on. That was absolutely fantastic. I appreciate what it's like being pushed in a room with someone you haven't met before and being asked to talk about your course, but you guys have done an absolutely fantastic job. I would like to wish you all the best in the rest of your studies. How long is your course, just to finish off?
2 years.
2 years. So maybe, looking at Simon off camera, maybe we try and catch up with you in about a year's time and find out how the course is going.
Yep.
And maybe we get the robots in.
Yeah.
He's off camera. Maybe we do. Who knows? Yeah, I'm getting thumbs up. Right, there we go. Perfect. But no, thank you so much for joining us. Absolute pleasure. Would like to wish you all the best in your studies. If you would like to know more about the T-level in engineering or any other courses that we have available at Darlington College, please do get in touch at darlington.ac.uk and find out more.